Well, in the second part here, we're going to look at simplifying roots. Well, if in simplifying roots, you want to take anything out of your root that you can, and you don't want to have a fraction in your root. If you do have a fraction in your root, you want to apply the root to the top and the root to the bottom. Well, the square root of 1 you should know is 1. Square root of 7 is in the bottom. Now you don't want to leave the square root in the bottom or any root. So you got to think, okay, I got to get that out of there. I want to try to end up with this in the bottom. Because the square root of a 7 squared, that square root and the squared undo each other. So you got to think the square root of 7 times what gives me the square root of 7 squared? Well, that would be another square root of 7. But if I multiply the bottom by that, I got to also multiply the top by that, because this is a special form of 1, and multiplying by 1 doesn't change it. So you multiply the bottom, you multiply the top. Now the bottom does simplify, the square root of 7 on top does not. So that's for the most part what you want to do when you have a fraction inside of a root. Apply the root to the top and the bottom, multiply by a special form of 1, and then simplify. Over here, we have an index of 4 in front, and we have some exponents that are higher than 4 on the inside, so we should be able to rewrite this. Also, 81, if you do the prime factorization of 81, is a 3 to the 4th. So there's your 81. I'm going to go an r to the 4th because it's a 4th root, and I still need another r to get to that r to the 5th. My s to the 8th would be an s to the 4th and another s to the 4th. So now I could take the 4th root of each one of these. Because it was all multiplication, I can apply the root to each one. The 4th root of anything to the 4th power is going to simplify. Now this 4th root of r to the 1st, that exponent of 1 doesn't match your index in front, so it does not simplify. And then these, your 4th roots, cancel out your 4th powers. Now you can multiply in any order you want, so you're going to get a 3r. S times s would be an s squared. Still have that 4th root of r hanging around. So here, square root of a fraction, we're going to apply the root to the top and the bottom. Square root of the 1 on top doesn't, or is just 1. So here, I'm going to go ahead and simplify this on the bottom, because I can think of a square root and an x cubed would be an x squared times an x. So then I can pull out this x squared inside of my root would become an x in the front. Can't do anything to my 3, my x to the 1st, or my y to the 1st. So now I'll have that here, and you got to think, okay, I have an x in front, so I'll have that. I want to somehow multiply this by something, so I end up getting this. It's a square root, so I want to try to get perfect squares down here. So you got to think 3, square root of 3 times what gives me 3 squared in here, and that would be the square root of a 3. And x times what is an x squared, and well, that's an x. And a y times a y is y squared. And if I multiply the bottom by that, I got to multiply the top by that. So this whole black thing here is a special form of 1, and multiplying by 1 doesn't change it. So I multiply the bottoms, I get the blue. Multiply the tops, I get this. So now the top isn't going to change. I'm going to have that x in front. This square root here is going to cancel out my squaring. Now in the bottom, I'll have an x times an x, so I could write this. Same type of thing over here. We're not dealing with a square root, it's a 5th root. So we could go ahead and simplify this. Notice 3 and 9 simplify down. Take a 3 out of the top and the bottom. Gives you a 3 in the bottom. Simplify your x's. Would you have to do it that way? No, but why not deal with something a little bit smaller if needed? It's a 5th root. Notice my exponent of 9 I should be able to do something with. And we also can apply the root to the top and the bottom. Now, looking at this here, we should be able to get that root out of the bottom. We want to end up with the fifth root of 3 to the fifth. So 3 to the first times what is 3 to the fifth? Well, that's the fifth root of a 3 to the fourth. So this will be my special form of 1. I'll multiply the top, and I get this. The fifth root of my 3 to the fifth just gives me a 3 in the bottom. Now, my 81, you should remember, is a 3 to the fourth. That exponent smaller than 5, I can't do anything with. But my x to the ninth would be an x to the fifth and an x to the fourth. So I have that. Now, my x to the fifth inside my fifth root would come out. Didn't do anything to the 81. My x to the fourth or my y cubed, so they stay on the inside. So try to do this one on your own and then watch the video. So here, I'm going to go ahead and simplify my roots, and then I'll multiply. Could you multiply and then simplify? Yes. So I'm going to simplify my roots. Write them as perfect squares. Anything that's a square comes out in front, so I get this. Write things as perfect squares and a little bit extra, make sure it's still equal. And then whatever squared, pull out in front. So now when you have this, you really have some multiplication going on. It's multiplication between here and here, multiplication between here and here. So you can multiply in any order you want. So basically multiply what's in front of your roots together, and then multiply what's inside your roots together. Now we can go ahead and simplify what's inside of our root. 50 is a 25 times a 2. We like 25 because it's a perfect square. So we'd have this, the square root of 25, square root of these squareds at the end. The square root of that 2 we can't do anything with. Now we can multiply our normal x, normal y with what's in front, and we get this here. When we're looking at this here, we have the cube root of this cubed. Well, the cube root and the cubing undo each other. And you might think, well, that happens down here. But remember, when we were dealing with this earlier today, that your cube root of something cubed, if it was positive on the inside, you got out positive. If it was negative on the inside, you got out negative. No big deal. And that's what we're saying here. Whatever the inside is, that's what you're getting out. But remember, over here, because it was an even root, we had to get out only positives that would work. And so to ensure that we get out positives, we have to use absolute value.